Okay, we're in Algebra 2, Mod 8. Hang in there, guys. We're getting there. Today is Friday, May 1st. We've made it to May. So, again, Algebra 2, Mod 8, guys. In your notes, top left corner, today's date, 5/1/20, Friday, May 1st. Yesterday, we did a topic called arithmetic sequences. Today, the second time of sequence we're going to recognize or learning about is called geometric sequences. And just like yesterday, remember for arithmetic, there was a pattern. You kept adding the same number each time to get the next number. Well, here we go. First thing I'm going to ask, look at these three problems. Might as well write down problems 1, 2, and 3 on your paper. And again, pose the question, what is the pattern? If I said play detective here and look at all three of those and see if you can see a pattern, like pattern recognition, could you find the next number in each one of these sequences? Well, number one, I think this one's pretty easy. It says 5, 10, 20, 40. Aren't we what? Multiplying by 2 each time? Think about it. If I took 5, what's 5 times 2? 10. 10 times 2 is 20. 20 times 2 is 40. Oh, so we're multiplying by the same number every time. Now, the number you're multiplying by is called your common ratio. They will use the letter R on a geometric sequence. So a geometric sequence is a sequence of numbers where the next number is found by multiplying each time by a common number, in this case, a common ratio, and the ratio would be 2. Do you agree? Now look at problem number 2. Go ahead and write down the sequence 4, 2, 1, 1/2, 1/4, 1/8, ... I could go forever following this pattern. Now careful. The first one, the numbers were getting bigger and bigger, so we knew the ratio had to be some number, what? Bigger than 1, didn't it? Well, if the numbers are getting smaller and smaller, okay, first of all, I'll forewarn you again, just like yesterday, we never said subtract. If the numbers were getting smaller, remember we said we're adding a negative number? Here, if the numbers are getting smaller, don't say, oh, I'm dividing by 2, dividing by 2, dividing. No, you're not dividing. You're what? Multiplying by a fraction, by a number less than 1. What's 4 times 1/2? 2. What's 2 times 1/2? 1. What's 1 times 1/2? 1/2. What's 1/2 times 1/2? 1/4. 1/4 times 1/2 is 1. Oh, so I'm multiplying by a ratio of a half. If the numbers are getting smaller, the number you're multiplying by must be a fraction. Does that make sense? And then even example number 3 here, look at the pattern. It says 2, -6, 18, -54. If you were trying to figure out that pattern, wouldn't you say we're multiplying by -3 each time? Because watch, what's 2 times -3? -6. But now take -6 times -3. You get positive 18. 18 times -3 would be -54. So it is possible to multiply by a negative number. So in this case, our ratio would be -3. Okay? So put a star and note that when you see a geometric sequence and thinking, what's the pattern? You're going to multiply each number by the common ratio. Okay? So now that I've written these 3 down and we kind of understand the pattern, we should be able to answer the following math questions. The first thing they'll have you do, so since we see a pattern, could you find the next 3 terms on each one of those problems? That's the easy part, isn't it? Especially if you got a calculator. Hopefully we won't need one. Let's see. Number 1, if you look back up at number 1, 5, 10, 20, 40. We keep multiplying by 2. So what's 40 times 2? 80. 80 times 2? 160. 160 times 2? 320. Piece of cake. Number 2, Ooh, careful. What was the pattern on number 2? We were multiplying times a half, weren't we? So pick up at the end where they left off and find the next 3 numbers. What's 1/8 times 1/2? 1/16. Times 1/2 would be 1/32. Times 1/2, 1/64. Okay, so take your time and use simple math. Use a calculator if you have to. And finally, number 3, remember on that one, the pattern was what? Multiply by -3. So now I am going to grab my calculator. We left off at -54. So -54 times -3 is what? 162. Times that by -3. So times -3 gives me -486. Times that by -3. And we're back to positive 1458. Okay? So we can do that. No problem. All right, then finally, a formula, just like yesterday. Look at the question I'm posing at the bottom of this first page of my notes. It says, go ahead and write a big star and write, how would you find the 14th term of example number 1 there up above? Now, number 1 was the one that said 5, 10, 20, 40. They want you to find the 14th term of that example. Now, of course, you're thinking, well, just write down all 14 of them and I'll see what it is. Guys, you don't want to write out 14 numbers in a row. Because again, I could have said, what's the 114th number? You sure don't want to sit here and write out 114 numbers just to find what it is. That tells us that there's what? A formula to memorize again. Agreed? So how do you find the nth term of one of these geometric sequences? So put an arrow down from that question. And in this big box, we're going to write down a really important formula. A sub n equals, that means the nth term of any geometric sequence is found by the following formula. It's not as bad as that one yesterday. Yesterday, remember, we wrote A1 plus parentheses n minus 1 times d when there was a common difference and it was arithmetic. If it's a geometric sequence, to find the nth term, in this case, we want the 14th term, a sub 14 would be our a sub n. To find the nth term of any geometric sequence, the formula is a sub 1, the first term, times whatever your ratio is, and that ratio is raised to the n minus 1 power. Okay, now don't panic. That's not nearly as bad as it looks. In fact, it's pretty easy. Watch this. So, for that question, how would you find the 14th term of example number 1 up there? The one that said 5, 10, 20, 40. Watch how easy. A sub 14, right? We're looking for the 14th term. So guys, n is 14 in this problem, isn't it? Because we're looking for the 14th number. A sub n would be a sub 14. So n is 14. A sub 14 equals, you take a sub 1, the first term, which was what? 5, right? Times, and then what was our ratio? I'll always put it in parentheses. The ratio, remember 5, 10, 20, 40, we were multiplying by 2, raised to the n minus 1 power. Since we're looking for the 14th number, 14 is our n. So 14 minus 1 is 13. Oh, so go to your calculator. We've got 5 times whatever 2 to the 13th power is. Just take 2 and raise him to the 13th power. That's going to be a pretty big number on your calculator. I'm getting 8192, right? And now I take 8192, that was 2 to the 13th, and I times that by 5 and get 40,960. Wow. 40,960. Who would have thunk that that was the 14th number of that sequence? You sure didn't want to have to write all those out. Let's try that again. Sequence number 2, remember, was the one that said 4, 2, 1, 1/2, 1/4, 1/8, etc. What if I said, what's the 15th number of that sequence? What's a sub 15? That's all that means. A sub 15 means what's the 15th number in that sequence? Well, there's already 6 of them written down. I guess if you wanted to keep going, you could write down the next 9 numbers in a row and figure out what the 15th would look like. I'm just going to use the formula I just gave you. A sub 15 equals, now remember guys, it's a sub 1 times r to the n minus 1. So here we go. A1, what was the first number? That was obviously what? 4 times, now what's the ratio here? Remember, you're multiplying by 1/2 every time, raised to the n minus 1 power. Oh, well, n is what? 15, isn't it? We're looking for the 15th number. So 15 minus 1 is 14. And guys, I don't care. As long as you plug the numbers in and get the right answer, you're taking 1/2 and you're raising it to the 14th power, aren't you? Doesn't that mean 1/2 times 1/2 times 1/2 times 1/2 times 1/2 times 1/2 times 1? I don't want, obviously 1 to the 14th power is 1. 2 to the 14th power, 2 caret 14 enter, is 16,384. But remember, that's dot connected to a 4, isn't it? Oh, so all I did on my calculator, since we had 1/2 to the 14th power, obviously 1 raised to the 14th power is just 1, right? This is not hard, don't be a baby. 2 to the 14th power was 16,384. Now there's a 4 in front of that, so obviously we're going to cross cancel the 4 and change this to, so go to your calculator and take that number 16,384 and divide it by 4 and get 4096. So guys, 1 over 4,096 would have been the 15th number in that sequence. If the original sequence has a bunch of fractions, then the 15th number should be a fraction, not a decimal. So you have to be careful and attack it like I did. Finally, number 3, that one that said 2, -6, 18, -54, the one that the ratio was, what was it, -3, agreed? They want to know what's a sub 12. What's the 12th number in that sequence? So here we go. Using the formula, again, I'm going to write it again just because I want to make sure I learn it. A sub n equals a sub 1 times r to the n minus 1. That's the formula you use to find the nth term of any geometric sequence. Equals, okay, here we go. I'm going to put an arrow. We're looking for a sub 12. So n is 12 this time. We're looking for our 12th term, aren't we? So a sub 12 equals a1, my first number is 2, times, what was our ratio? -3 raised to the n minus 1 power. So we're looking for the 12th term. So 12 minus 1 is the 11th power. It is not that bad. Okay, always do what's in parentheses first. So guys, careful on your calculator. You've got to put that negative number in parentheses. Don't just type in -3. Put parentheses -3 raised to the 11th. So parentheses -3, parentheses caret 11. -3 raised to the 11th, oh gosh, is negative 177, 147. I'm timesing that by the 2. So on your calculator, that big negative number that's on there, hit times 2, enter. Wow, who would have thought that the 12th number in that sequence would have been negative 354,294. And that's how you find the nth term of a geometric sequence. Okay? All right, it's not as bad as it looks. Keep your notes with you when you try your homework so you can look at your formulas and not get confused. All right? All right, good job. Thanks for hanging in there. Your homework, since today is Friday, May 1st, right? You got all day today to work on this. That'd be great. You get it done. You don't have to worry about it over the weekend, or you've got Saturday, Sunday night, and even Monday morning. But these 3 problems, so hit pause on your video so you can write down these 3. Basically, you've got a sequence, and a sequence. You're finding the next 3 terms on all 3 of these. And then for the first one, you want to know what's the 13th number. For the second one, what's the 10th number? And for this third one, what would be the 9th number by using your formulas there. So this would be due Monday, May 4th at noon. Finding the next 3 terms and the nth term of a geometric sequence. So great job. Have a great weekend. Keep working. We're getting there. Again, that's due on Monday by noon. We'll see you then. Bye.